Robust process design. In quality management, we should always try to reduce variability or even eliminate it if we can. But at some point we reach a situation where it is just too expensive or maybe even impossible to reduce variability further. And in this case, we might discover that the alternative is attractive. The alternative to reducing variability is designing a process that takes a variable input and still produces good quality products. And so a robust process will be defined as a process that works well, right, that delivers sufficiently high quality products despite large variability of some inputs or some parameters. And the analogy here is, imagine a tennis player. A tennis player should always aim to hit the ball with the sweet spot of their racket, right? That's, that's what makes a good tennis player. But at the same time, the tennis racket should also be forgiving in that it does not lead to a poor shot the moment the hit is less than perfect. So we will say that this tennis racket should be like a robust process, right? Despite some variability in where the player hits, right, in which spot the ball touches the racket, still the the shot should be of good quality. So this is, in a sense, the racket should be robust. This is the analogy to the robust process design. So this is an example of a robust process design. Suppose we're baking cookies, and we defined some kind of measure of ideal chewiness, right? So we say a chewiness should be between 17 and 18, and if it is there, then we have cookies that are much more delicious than if the chewiness is less or 17 or less than 17 or more than 18. Which baking process should we use? And imagine we have two designs. Design A, we bake for 24 minutes in 240 Fahrenheit temperature. And design B, bake for a shorter time, 21 minutes, in a higher temperature, 285 Fahrenheit. Both of those can deliver the chewiness in that range. But, right, notice what happens actually if you study the space of those two dimensions. The time, here the time is right from somewhere 21 to about 25 minutes baking time, and the temperature, right, varying from around 240 to 300 Fahrenheit. And notice what happens if you choose design A, right, and this is the point, right? You get the chewiness between, this is the line for 17, this is the line for 18, the point is here. If you choose design B, you get this point. But the problem is not just the point, the problem is variation, right? What if you don't get the time exactly 21 minutes? It varies a little bit. Maybe you bake a little bit less, a shorter time, or a little bit longer than necessary. Here the same, right? And what if you don't get the temperature exactly set? Maybe the oven, the thermostat is not working very well, and the temperature becomes a little bit too high or too low for maybe regularly all batches or for some batches. You will see that, right? The circle that is here representing some variability around the point, in this circle reaches chewiness of almost 14 or all the way to something like 18 and a half, right? If these are the lines. So here, the chewiness that you can achieve with this process, especially when the temperature is varying, is much broader, and therefore you might have poor quality cookies, right? If the temperature is only a little bit higher, you might go outside of this ideal range, 17, 18. Whereas design A, you will see, even with this variability, you're still within the range 17, 18. You're actually at the borderline here of 18, right? But that's an extreme variation in this circle, but the circle practically fits within the range 17 to 18. We might maybe increase the time a little bit and make it even better, but clearly this picture shows design A is much more robust, right? Given that temperature may vary, and given that, of course, time can also vary, but temperature is especially sensitive here, right? The design A is much better or more robust than design B, and therefore it should be preferred. So you see, this is an example where we can design a process that can accommodate for the variability, and despite variability, in this case, in the temperature or in the baking time, can produce products of sufficiently good quality.